My name is Michael Snoyman. I'm going to be speaking today about strongly typed financial software. There we go. So, what is Rust? Fair question. We have a bunch of terms. I'm not going to go through everything on the slide. You guys can read yourselves. Rust is a lot of different things. The thing I tend to care the most about is types. I love the idea that the type system is able to protect you from making mistakes. So the things that I'm going to focus on, things like statically typed and strongly typed, and a bunch of other things as well. I just included this because I really like this meme. Okay, but let's talk about, Let's talk about statically typed versus strongly typed. Statically typed is very simple. It means are types checked at compile time or are they checked at runtime? Anyone who's ever seen Python and gotten a type error from Python, you know that Python doesn't actually do that at compile time because there is no compile time. It does it at runtime. By contrast, a language like Rust or Haskell or C, those are all statically typed. By contrast, strongly typed is a little bit of a difficult term to define. Strongly typed, I would define more as a spectrum. You can be more weakly or more strongly, but there's a range in between, and that's going to be a lot of what we're going to see in this talk. So what are some of the strong typing features in Rust? Some types, anyone who's ever heard me talk about this stuff, you know I love some types. Some types I think are one of the greatest underappreciated features. New types, new type wrappers, and the fact that they are so easy to do in Rust is another wonderful thing, and many other things. We'll touch on a few of these also. One of the things I always hear people say when they advocate for dynamically typed languages is the idea that, well, I don't want to have my compiler break things. That's completely backwards. Every single time my compiler refuses to compile the code, it means that there was some kind of a bug that was prevented at runtime. I know someone's going to say not every time, fine. But that's the idea. So I want my compiler to stop me. And that's the entire idea of strongly typed. Can I make my code set up in such a way that many bugs are caught by the compiler instead of needing to wait for a test or a production crash? Now, we're talking about financial software today, and the question is why? What's special about financial software versus other kinds of software? One, precision in the numbers matters much more in financial software than possibly any other place. You may say things like the space shuttle matters more. It actually doesn't for the most part. Usually floating point, when you get to scientific calculations, is good enough. When it comes to financial software, you can go to jail or get fined or whatever it is if you screw up the rounding. Anyone who's seen Superman 3 knows what I'm talking about. Mistakes can lead to that, but also intentional issues like the Superman 3 case. It's also very easy to mix up different kinds of numbers. Now, like the Columbia shuttle crash, everyone knows about this famous story. Inches versus centimeters, and a shuttle explodes. But we have a lot of the same things in the financial software world. For example, what we're going to be seeing today, let's say that I wanted to create an application to exchange dollars for euros. Those are two different things. You can represent them using the same numbers, but do you ever want to accidentally use euros when you wanted to use dollars? The answer is no. Also, another kind of concern. There are plenty of things in the financial world where you want to be able to ensure that you do not have negative values, or you don't have zero values. We'll see some of those later on. To start off, everyone go ahead and have a look at this bit of code and tell me what's wrong, or think, because no one's going to yell out, but go ahead and think about what's wrong with this code. I heard currency. What do you mean? We don't, well, right now, don't even worry about making it better. The code is just straight up broken. So, floating point, perfect. That's one issue. Another issue is look at that calculation. I took the price of apples plus the price of bananas. That doesn't make a lot of sense. And then I multiplied that by the number of apples and the number of bananas. Now that's wrong, and anyone who's doing code review will probably catch that, but maybe not. It's actually very easy for something like this to slip under the radar. The question is, can we set up the code in a way that a mistake like this simply can't happen? So decimal type is definitely one thing that we can do. That's going to address the floating point issue. And another change we're going to make is we're going to add in new type wrappers. Now, new type wrappers are like that struct example that you see up there, struct price and struct USD. And what we've done is we've now created two completely different types to represent the different kinds of currencies that we could be dealing with. I've also sorry, that was actually backwards. One thing for prices and one thing for the total amount of dollars. Sorry, I'm jumping ahead to the euros. I also have this, this method on price called calculate total. And you give it the quantity as a U32, and it calculates the total amount. And you'll notice that the way that that function is set up, it's actually telling you we're going to take a price and a U32, and we're going to spit out a USD. There's no way to accidentally put in a USD as the quantity or any other kind of mistake you might want to make. And if I write the code the way that I did before, firstly, we of course have to wrap things up in the correct types. It doesn't help us if we don't use the types that we wrote. But once I wrap up the prices in that type, you can see we actually get a very clear error message from the compiler saying, what are you doing? You can't add two prices together. That's not a logical change computation you can perform. This is how we can go ahead and we can change this. We can take advantage of the really nice operator overloading that's available in Rust. We can define an add impl for the USD. And we can say we are now able to take dollar amounts and we can add them together. Adding them together is very simple. It's just reusing the underlying operation. And we can also, just for fun, have a display impl. And this display impl always shows 2 decimals of precision, which is, and puts a $sign in front of it. These are all very nice things that we can get out of this. And then, for the implementation, we once again have price. It's a little more complicated with the decimal stuff, but we have the prices, we have the quantities, and now I'm able to use priceapple.calctotal, pricebanana.calctotal, add these two things together using the new add impl that we put in, and we now have the correct answer. And if you tried to do anything else using these types, it's going to fail. And that's exactly what we want. We want the compiler to stop us. There's always room to go further. I told you that strong typing is a spectrum. So we went from weak to medium. We could also go farther. This would be an example, and I'm not going to go through all the details. Feel free to read them. I would argue for an example like this is overkill. And if I'm being very honest, even the previous slide is overkill for an example like this. It's one stupid little function that's 5 lines long. But the point is, when it comes to strong typing, you always want to choose some kind of a cutoff point where you're saying the amount of effort I'm putting into the system is correct, given the benefits that I'm getting out. Or as an economist, the cost-benefit analysis. So what am I going to do? I'm actually going to start looking at much more code and talking a little bit less, I hope. We are going to be building what I'm going to call a spot swap application. This is based off of some real-life, real-world code. Happens to be in the blockchain space, but we're not actually doing any blockchain stuff here. We are going to build a server. It's going to be using Tokyo and Axum, in case anyone's curious, and a client. The client is using Leptos, because I think Leptos is really cool. You should be aware of the things that I'm going to put in the slide. Caveat emptor means buyer beware. So I am warning all of you in advance. There are a lot of things in these slides and in the sample code that I wouldn't actually recommend for practical real-world code. One of the biggest examples, I'm redefining decimal types, and I shouldn't be doing that. Everything I did here was for, I don't actually remember how to say pedagogical, whatever, for teaching purposes. So just take that into account as you look through the code samples. First thing we're going to look at is we're going to look at the numerics themselves. We want to represent money. Now, we already saw that there's this thing called Rust decimal, but you're going to see why it is that I'm defining some new types to help us out here. First thing, encapsulation. Now, that might sound like a scary term because it's an OOP term. Everyone hates OOP. One of my premises is that there's a lot of good things in OOP and lots of other kinds of disciplines, and we have adopted the best of them. So encapsulation is something that we can do in Rust. Here, what you can see is I have created a private module. Inside this private module, I have declared a data type called unsigned decimal. This is the first piece of the puzzle that we want to do. An unsigned decimal represents the idea that this number cannot be negative. It can be 0 or higher, and we represent this decimal using a U128. The idea is that we're going to assume that there are 6 decimals of precision. This is a fairly standard way of doing fixed precision representation. But importantly, notice that the field value is not public. The only way to access that field, and therefore the only way to construct an unsigned decimal or look at its underlying representation, is inside this private module. Also within this private module, I define 2 helper methods, from raw value and get raw value. These are the ways that I'm going to be able to convert to and from a U128 throughout the rest of my code. And the idea is I now have this very clean interface that the rest of my code can use, and I never have to worry about any invariants being violated. Now, you might be wondering, what kind of invariants am I talking about? Turns out for this code, there are no invariants. But the next thing I'm going to deal with are signed decimals. Signed decimals are going to build on top of those unsigned decimals, and we're not going to do anything fancy like 2's complement. Very simple. We're just going to stick a negative, and it's going to be a bool. Can anyone tell what the problem is with that while I grab a drink? Say again? Double zero. Exactly correct. There are currently 2 different ways that we could represent 0. It could either be 0 negative or 0 positive, which doesn't make any sense. So we now have a defined invariant in our code. It is illegal to create a negative 0. Because if we did that, equality wouldn't make sense anymore. This is actually a very common problem that decimal libraries have to address. Now, at this point, the private module begins to make a lot of sense. You can look at our implementation of from raw value, get raw value, and is negative. All of these are able to work with the internals. There's nothing very interesting about get raw value and is negative, but from raw value is where the magic lies. Inside that method, you can now see we are actually checking if the value is negative, and if it's 0, then just get rid of the negative part and treat it as a positive. And this means we can all look at this code right now, and we can all be pretty well convinced that there is 0 chance, without reaching into unsafe or other kinds of evil things, there's no way that you would be able to create a negative 0. This is great. This means that now through the rest of my code, and you guys can all look at the code later if you feel like it, throughout the rest of my code, I can provide display impls and everything else that I could possibly want, parsing impls. And no matter how poorly I write that code, I never have to worry about this invariant being violated. In that previous example, I simply ignored the case where someone tried to create a negative 0 and turned it into a positive 0. But here's another example. In this example, I am creating a positive decimal. So positive here meaning greater than 0. No 0 value is allowed. So I'm still using the same unsigned decimal under the surface, but this time I have to check and ensure that the user hasn't, or the caller, I should say, that the caller hasn't provided a 0 value. And in this case, I'm actually using anyhow's result type. Many people would say don't use anyhow in this kind of a case. You shouldn't, probably. Library code should probably be using more well-structured types, but we're not going to do that here. Go ahead. So here, we return a result. And this allows us to capture the fact that we are not allowed to have 0 values. Once again, all of the same rules that I told you about encapsulation apply. And so what you can see here is Rust has given us encapsulation and newtype wrappers, and this has allowed us to create very powerful libraries, very powerful types, without having to worry too much about the correctness. You can see this as one of the examples. I've implemented from stir for positive decimal. You may notice there is no line in here that says anything about the number 0. So how do I know that this is safe? Well, one, I already know it's safe because of the encapsulation. Can anyone tell me where the check for 0 occurs in this code? Bingo. It's positive decimal new. We are forced by the type system to make sure that we use and then, or something equivalent there to that. We receive a result after we call positive decimal new. The only way to construct a positive decimal is using that method, and that method will always check for 0. So we're completely safe. OK, that's it for the numerics. Next phase. We're now going to be dealing with assets. So assets in this application could either be dollars or euros. I'm going to say USD in the code, but dollars and euros. We could use the decimal type for this directly. That would not give us the correct kind of strong typing guarantees. You'll see this code later on, but I'll tell you now. For real, I'm not lying, and I'm not just making this up to make the talk look more interesting. I really made a real bug in this code when I wrote it originally because I didn't use the asset type strongly enough throughout the code base. You'll see what I'm talking about. So even for someone writing a simple application, which this is very simple, the types did end up coming in and saving me. So this is the way we're going to do it. We're still using the same unsigned decimal, and positive decimal and everything else under the surface, but we're also introducing a type parameter. Now, this type parameter doesn't get used by anything. Therefore, we have to throw in a phantom to deal with that. All this is doing is it is a compile time claim that this is dollars or euros. It disappears at runtime. It has no performance overhead. The only reason this exists is to prevent code from compiling. There's a little bit more with the representation, the binary representation, but for the most part, my goal is stop the compiler from working if I screwed something up. Next, I'm going to introduce this asset trait. The only purpose of the asset trait is so that I can display USD or euro as something when it gets serialized into a binary representation. And then, on top of all of this, because there is a lot of boilerplate when dealing with these things, it generally is really nice to be able to define a macro, yet another great feature of Rust. So you may be noticing the point here is we want to be able to do all these great things and make them as easy as possible. The more you're able to reduce the friction on performing these operations, programmers are more likely to actually do it. I've done crazy things like church encoding in Java because they don't have sum types. It sucked. Everyone hates it. No one wants to do things like that. If you make it nice and easy, people will do the safer thing. OK. So this, as one little example, is code that does not compile. And you can see we're trying to add dollars and euros together. And I haven't shown you the impl for add for these types, but you could probably guess what it does. And it does, in fact, check that we are adding two of the same assets. There is no way to add dollars and euros together in this kind of a setup. The final thing the final data type we're going to represent is prices. Prices are a little bit different than the other things we've seen because in this case, we're no longer just going to say the price of apples in dollars. We're actually going to say something a little bit more sophisticated. It's the price of dollars in euros and the price of euros in dollars. If that makes people's heads hurt, that's completely normal. These things get very difficult once you start talking about two different monetary systems. People make mistakes all the time. We have terms for them. It's called base and quote. So base is going to be the thing that you are trying to buy, and quote is the thing you are going to try to buy it with. So for example, if I'm talking about going to Europe and I have some dollars, I may need $1.03 to buy 1 euro. In that kind of a setup, we'd be talking about the base being euro, the quote being dollars, and the value being 1.03. I am able to calculate the, OK, sorry, one little back step. The way that in these kinds of swap applications, at least it's something called an AMM, an automated market maker, in those kinds of a setup, the way you determine the price is by comparing within your system how many dollars and how many euros you've got. The ratio between the two of them is the price. And so that's what I'm going to define here as the from asset ratios. I take in the base value and the quote value, and you'll notice that I put it down as positive asset. Because it's a positive asset, I know that it can't be 0. And therefore, you'll notice there is no check here to confirm that I didn't do a divide by 0 because it's impossible to do a divide by 0. OK. Next, now that we have all of our base data types defined, now we're ready to start talking about our APIs. Once again, this is just a simple talk for now, and therefore I didn't do something more sophisticated. More sophisticated here would be something like gRPC or an open API Swagger, something along those lines. Instead, I did a very simple representation of an API. This is all using an enum, showing all of the different requests that can be made. And then on the right-hand side, you can see some of the responses that can come out of these different requests. You'll notice that throughout this, we actually, now that I'm looking at it carefully, we have no raw types on the left-hand side. There's not a single U32 or anything like it over there. Even when we request the balance, I've introduced a new type owner to wrap up a string. And this is something that I strongly recommend people do if you want to do strongly typed code. Avoid using the raw types because it is way too easy to accidentally swap things around. All right, let's see an example of the server-side code. This is an example of the status endpoint that I've defined. I told you guys that I was using Axum. So this is async Rust using Axum, and we simply load up all the data. There's some locks. There's some other interesting things. None of that's particularly interesting. But you'll notice total USD, very trivial. I took the unsigned assets. I constructed it from the balances, added, boom, done. And there's no possibility to create a bug if these things are defined correctly. Now, someone may actually be looking at this and realizing, wait a second, why did you have to wrap up balance.usd and unsigned asset? That's the bug that I told you about earlier. In this version of the code that I wrote, I didn't actually use the asset types correctly. I still used the underlying decimal types. Balance.usd and balance.euro are both just raw values, and I have to wrap them up in this part of the code. This is an example of things not being strongly typed enough, and this is exactly what leads to bugs. By using the correct strongly typed values or types all throughout the system, we're able to prevent that. I'll show you the actual bug, I think, on the next slide. Oh, here we go. I was right. Who can see the bug? Say again? Exactly. I tried to take a dollar amount and I subtracted euros. This was a very trivial mistake to make. I can tell you exactly how I made it. It was a copy-paste error. I copied some code, put it in here, noticed that I needed to update one thing to USD, but I didn't catch the other one. I started running the application. Things just didn't work. It actually took me about 30 minutes to debug this. I'm an idiot. But thankfully, when I do things correctly, the compiler can actually stop me from ever making this mistake in the first place. It is so much nicer to be sitting in my editor and get a red squiggly on exactly the line of code that's broken, as opposed to having to stare at a web browser and wonder, why the hell can't I buy dollars right now? Which is what happened. This is the change that I made in order to fix that bug. And you can see, like I said, I was an idiot previously, and I had used unsigned decimal instead of unsigned asset to represent these balances. Why did I do that? Brain fart. Doesn't really matter. I did make that mistake. Once I fixed that mistake, it's not that I fixed a bug. I eliminated an entire class of bugs from ever coming back into the system. For this application, I said I used Leptos on the client side. I think Leptos is very cool. It's also very difficult to get started with in some cases, but overall, I think it's got an amazing model for front-end development. I would definitely recommend checking it out if you haven't seen it. Even just playing around with it is great. This is the heart and soul of the entire client-server interface. The client-server interface is simply set up as a single JSON endpoint. We send in those requests. It's all that large enum that I'd shown you previously. There is a little bit of ugliness around the fact that we don't know the response type. That's something that a good library like a gRPC library or Swagger, those would fix this. But this is good enough for demo purposes. And you can see we are able to serialize and send the request, get the response deserialized, and everything is in shared types. I love this kind of an approach. I'm working on another project right now using exactly this kind of a thing, and it is a godsend. The component code is pure Rust. And therefore, all of the wonderful things that all the wonderful things I already implemented in the types that are being used on the server immediately translate to the client. One little tiny example, you'll notice that I'm able to use .toString everywhere. So once I've implemented display, I am now able to use that everywhere. And the display that I implemented, which I'm not including in the slides because limited time, it actually serializes for display. It includes what asset type we're talking about. So instead of just saying 100, it says 100 USD and 100 euro. So it's convenient, and that's all based off of the types. I also decided, and this is probably overkill, I don't think I've seen anyone do something like this before, but I decided why the hell not. For the on-the-wire representation, we also encode in it what kind of an asset type is being used. So you'll notice that for euros, it says 10 euro instead of just 10. This means that if a client uses the wrong types, uses the wrong representation, it could be that there's a client written in a completely different language that isn't using our types. Nonetheless, at the boundary, this is a term back from my Yesod and Haskell days, at the boundary, we check, confirm that everything is correct, put it into strong types, and once it's in strong types, it is now inside our completely safe system. That is the end of the main content. I went through it a hell of a lot faster than I thought I was going to be able to. There's quite a bit of code available. Since I'm not on my machine, I'm definitely not going to do the live demo. But if anyone, I guess we have a little bit more time for questions, if anyone had any questions they wanted to ask about this.